All right, guys, we will get started with today's webinar. Welcome to today's topic, hands-on UI testing with Python. Just going to do a quick intro of today's presenters. My name is Nick Brown. I am the marketing manager at CrossBrowserTesting, a SmartBear tool, and I'll let my co-host do a quick intro as well.
Hey, y'all. My name is Andy Knight. I am a software engineer and test at Precision Lender in Cary, North Carolina, but you may also know me as the Automation Panda for my software development and testing blog.
Thanks, Andy. I'm just going to do some quick housekeeping. SmartBear was founded in 2009 in Boston. We've grown to over 11 global offices encompassing North America, Europe, Asia, and Australia. We have over 6 million developers, testers, and operations professionals from 20,000 plus companies like Google, RBC, and Vineyard Vines use tools every day to deliver bug-free software. We're a company of over 500 employees that also provides 5 free tools for the community, including 2 wildly popular open source tools, Swagger and SoapUI. As you can see here, it shows a quick depiction of all the products that SmartBear does offer. We do cover the entire SDLC from planning and design to testing and monitoring. And I'm going to hand it over to my co-host, Andy. But before we do get started, I just want to say, as we go through this presentation, if questions do come about, please direct them to the QA section. We will be sure to get to as many as we can at the end of the presentation. Thanks.
Thanks so much, Nick. And thank you, everybody, for coming today. I'm really excited to collaborate here with SmartBear and my friend Nick, as we're going to talk about some awesome stuff. So as I said, I'm a software engineer and test, and I do web UI testing day in and day out as part of my day job. I know from firsthand experience that web UI testing, and particularly test automation, can be very hard. What we're going to talk about today is how we can make it easy with the power of Python and also cross-browser testing. This will be our agenda for this afternoon. We'll talk about what is web UI testing, just as a brief intro. We'll look at writing a simple test case together. We'll look at how to make browser interactions with a real live browser. We'll talk about how to scale that test to cover multiple browsers using cross-browser testing. And as Nick said, we'll finish up with a live Q&A and hope to get to as many of your questions as possible. So hold on to your questions for the end there. I'd also like to shout out that all of the example code you'll see today is hosted in GitHub. My username is AndyLPK247, and the test project that we'll be writing together as part of this webinar is at SmartBear Hands-on UI Testing Python. You can check that out after our webinar today, give it a trial run, and even extend it for some testing of your own. So let's start by talking about what is web UI testing. When we talk about web UI testing, I'm talking about black box feature level testing of a web application through a real live browser. It's supposed to simulate kind of what a human user would do when they interact with your web application. So they would log in, they would do searches, they would go to their profile, they would upload stuff, all the basic user interactions we can automate. And because of that, it is very much feature level testing and not so much code level testing. Furthermore, this style of web UI testing is also end-to-end testing, because all of the parts that make up that web application are implicitly exercised through the user interface. When a user makes a request or does a search or whatever in the browser, behind the scenes, there's a lot of back-end stuff that happens. Service calls, queuing, worker threads, load balancing, all that stuff that should be seamless to the user through the UI. So if we can do web UI testing effectively, we know that we basically have a good end-to-end test. However, web UI testing is expensive, right? It is difficult. The code it requires is more intense than, say, unit testing or integration level testing. There's problems such as race conditions, changing pages, changing features, and the WebDriver interface, which can be a little bit complicated. So because web UI testing can be expensive and also rather slow, we want to focus on writing good tests that have significant return on investment. Our web UI test should exercise critical paths, most important features, and we want each test to focus on individual behaviors. So we have a separation of concerns that will make our tests more sensible, give better results, and really be more reliable. So web UI testing is great. It's expensive. Let's focus on ROI. In this webinar today, we'll show how to build a very basic web UI test automation solution using Python. Why Python? Because Python is awesome. I personally love Python very much, and I find it's very easy to get big things done quickly with minimal amount of code. Along with Python, we'll be using a couple tools. Our core framework will be pytest. For our user interface interactions, we'll model those using the page object pattern, which you may or may not have heard of. For the low-level browser automation, we'll be using Selenium WebDriver. And finally, to scale to multi-browser testing, we'll be using CrossBrowserTesting as a cloud-based tool. If we wanted to look at our solution sketch as a diagram, it would probably look something like this. Here's how all the pieces fit together. Every test case will be written as a pytest function. Within those test functions, there will be page object calls being made for high-level interactions, things like searching for a phrase or logging into the web app or scraping results from the screen. Inside the page objects, we'll be making low-level Selenium WebDriver calls, the clicks, the send keys, the scrape text. Those low-level interactions will be inside of page objects. Then, all that Python test automation code will communicate to a proxy between it and the actual browsers under test. If you run the tests locally, you'll need a WebDriver executable for the appropriate browser type. In our webinar, we'll be using Chrome, which means if we wanted to run locally, we would need to install the Chrome driver, which is a separate project. We would install a Chrome driver on our local machine and make sure it's on the system path so the terminal can access it. If you want to do remote WebDriver testing, your intermediate body will be something like a Selenium Grid hub, or in our case, the cross-browser testing service, which we simply make as a request out to the cloud to get our WebDriver session. That intermediate proxy will then communicate back and forth between the automation and the browser under test so that both are in sync with each other. Now that we know what web testing is all about, let's write our first test together. For simplicity today, we're going to write a basic search test for the DuckDuckGo search engine. Why did we choose this? A couple reasons. First of all, it's free. Secondly, it's got a fairly simple user interface. And third, pretty much everybody knows how to use a search engine. So as I said, let's write a basic search test together. Before we do, I want to make a point very clear. It is always a best practice to write your test case first before you write your test code. As an SET, I will always try to play with the features, explore them a little bit, and I'll write my test cases out in plain language English steps. And I'll do that before I ever touch code, whether it's Python, C#, Java, whatever. And the reason why is because test cases are a separate concern from test code. right? Test cases are what we want to exercise for the behavior. Test code is simply an implementation of automation to cover that test case. I find if I jump into the test code too quickly, I'll get distracted by other issues and I won't think as clearly. So always, always, always write your test steps before you jump into your automation code. So let's build this test case together. If we're going to do a basic search test, the very first step is we need to load the DuckDuckGo homepage. From there, we can do a search. For our test case, we'll search for a basic phrase like panda, because I love pandas. We'll type it in, and we'll hit the return key to submit the search. Once the search has gone through, DuckDuckGo will display a results page. And our test should verify key pieces of information on this results page to make sure that the behavior worked as expected. One of the things we can check is to make sure that the query string appears in the page title, circled here in red. Another thing we can check is to make sure the search input field also still has the search phrase. And finally, where we really get the value is knowing that the results returned somehow pertain to our search phrase. What we can do is we can scrape all of the result links and do some string matching to make sure that some of them contain our search phrase in them. Now, as I said before, this is nothing but a basic search test. There are many, many other behaviors at play here that we could cover, but we just want to do enough to make sure that if we search for something, we get something back that lines up, right? I would encourage you after our webinar to download our example project and try to write some additional tests for things like what happens if you click one of these links, or what happens if you search for other phrases. Personally, I like to write my test cases using the Gherkin language. If you're familiar with behavior-driven development, or BDD, this will seem second nature to you. If you're not, just as a quick overview, Gherkin scenarios write their steps in given, when, then formats. It's very similar to the arrange, act, assert pattern for testing, if you've heard of that. In our basic DuckDuckGo search test case here, we say, given the DuckDuckGo homepage is displayed, when the user searches for the phrase panda, then we expect these three things to be true. The search result title contains panda, the search result query is panda, and the search result links pertain to panda. Even if I'm not using a BDD test framework, I'll still write my test cases out like this in plain language in the Gherkin format. Now that we have a test, let's put it into the pytest framework. If you're new to Python, you may not have heard of pytest. Pytest is one of Python's most popular test frameworks. There are a couple other frameworks in Python like unit test or behave, but personally, I really like pytest. And the reason why is because it is concise, clear, and Pythonic. This screenshot here comes from the pytest.org homepage, and it shows just how nice pytest is. The example code for the inc function is just some function that adds one to a value. The example test is right below that, and it's only 2 lines long. In pytest, you write your tests as functions. You don't need a test case class. You don't need setup or cleanup methods and test methods. You use functions, which are a greater buttress against side effects. All test case functions in pytest start with test underscore. And inside, you make your test case calls. What's also nice about pytest is that there's no assertion library. We simply use the basic assert statements from the Python language, and pytest will introspect on the values and do logging to reveal what the actual values were when a test fails. So we can see very clearly PyTest is simple and concise. I'm not going to talk too much more about how to use PyTest or what some of its advanced features are, but rather in this webinar, we'll just kind of use PyTest as our framework, and I'll explain important things like fixtures as we go along. If you want to learn more about this framework, which I highly recommend, here are 2 books that I've read myself and can personally endorse. Python Testing with PyTest by Brian Ocken, as well as PyTest Quick Start Guide from Bruno Oliveira. Both of these books give great examples, tutorials, and all sorts of great documentation to help you get started using PyTest like a pro. To get started with PyTest, all you need to do is a simple pip install in your project for the PyTest module. The typical way that people will put PyTest tests inside of their project is to create a tests directory underneath the root project directory. And inside of there, put a bunch of Python modules prefixed with test underscore. If you use this naming convention, then PyTest will automatically discover all test functions in this module, in this folder, when you run the tests for your project. Here, I've created a test basic DuckDuckGo search test function. And right now, it's nothing more than a stub. You can see I've put the test case steps in comments, and I've added to-do comments that will fill out as we go with the test case steps implemented. If you're wondering about that exception at the bottom, that's nothing more than a placeholder to tell me that this test hasn't been written yet, because I don't want to have false positives. Always, always, always write your test steps first, and I highly recommend you use that as the starting point for your automation with comments. Now that we know what tests we're going to automate, let's look at automating those browser interactions, because that's where the real meat of our web UI testing comes from. As I mentioned before, Selenium WebDriver is the package for web browser automation. Selenium, as a project, releases their WebDriver implementation in all the major languages, whether it's Python, C#, Java, or Ruby, or others. The Python implementation is the lowercase Selenium package, and it contains all of the web UI commands that we will need to send commands from our test automation code to a browser. What's really nice about WebDriver is that as an interface and a standard, it can handle every type of web UI interaction that you would need, whether it's clicking, sending keystrokes, getting things from the page, interacting with select elements, it's all there. There's nothing we can't automate inside that browser. However, as part of our design, and we'll get to this in a little bit, we want to write all of our WebDriver calls not directly from our PyTest functions, but from these page object classes so that it's more reusable. The WebDriver calls, as we'll see, can be rather low level and sometimes confusing. If you did a Google search for Selenium WebDriver Python, you'll probably end up at this documentation page. Personally, I refer to docs like this all the time, even though I use Selenium every day, simply because the API is very large, has a lot of different stuff, and I can't always remember what the syntax is or the specific methods or properties that I need. So I recommend having a window to documentation like this open as you go about writing your tests, because it's very helpful. Just like with the PyTest package, we'll install the Selenium package with a simple pip install. And that's all we need. As far as setting up the WebDriver, there are a few things we need to handle to make sure we do it right. First of all, we want to make sure that every single test case has its own WebDriver instance, meaning its own browser instance. At the start of the test in a setup, we should initialize our WebDriver with all the options we need and make sure it's ready to go for testing, so to speak. And at the end of the test case, we need to make sure that we quit the WebDriver so that the browser process is killed. Otherwise, you might have zombie processes running on your machine. You don't want 47 instances of Chrome locking all of your directories, especially if you're on a CI build server. And also, we want to make sure every test case has its own WebDriver instance to protect test case independence. One test case should not affect another test case. Setting up and tearing down for each test case, although it may be a little bit more time consuming in terms of our testing runtime, it's a much, much safer practice. And it avoids problems with Selenium living too long and possibly getting in a weird state. In the pytest framework, the way in which we will set up and tear down our WebDriver instances is using what we call fixtures. If you're new to pytest, think about a fixture as a setup method and a teardown method all in one. I love fixtures because they are functions and they can be applied to any test case anywhere in your solution, which makes these setup and cleanup routines much, much more reusable than your more traditional unit test or JUnit style setup and teardown methods. I recommend putting all of your fixtures in a file called conftest.py in your testing folder. Conftest.py is a standard Python module, or a standard pytest module, excuse me. I didn't come up with the name. It's set by pytest. But when pytest runs, it'll visit this module first and get all of the fixtures. So that way they can be shared by any test modules. Our fixture here is named browser. And what this browser fixture will do is set up the Selenium WebDriver instance for any test that requires this fixture. Just to note, this implementation will be for a local browser, meaning since we're using Chrome, we must also have that Chrome driver installed on the system path. Later in our webinar, we'll come back and we'll refactor this in order to handle cross-browser testing. But let's talk about the local case first because it's simple. The first line, b equals Selenium WebDriver Chrome, that is the call that will initialize the Chrome driver on your machine. It'll happen locally on the machine running this pytest test. And the b object will have a reference to that WebDriver object. The next thing we do is we want to set an implicit wait time. I mentioned before that web UI testing is prone to race conditions. And by that I mean there's a difference in time between when you could send a command and when the page in your browser has actually rendered that element. If those two don't line up, then you may be misfiring. You may be trying to click an element that doesn't exist, and then you'll get all sorts of nasty exceptions. A simple way to handle that is to put an implicit wait in place. For local testing, I typically find 10 seconds to 30 seconds is a good implicit wait time. Now, whenever I try to interact with the browser, if the thing I'm trying to hit, such as an element or something, does not yet exist, the WebDriver instance will automatically wait and check again until that timeout is hit for the target element or whatever to appear. That way we don't need to write a bunch of explicit waits all throughout our code base. The third line here is the yield, and this is a pytest fixture thing. Yield acts like a return statement. So it will return B, the browser instance. By returning it, other test cases that call this fixture can access the browser. However, anything after the yield is essentially the cleanup version, or the cleanup portion of this fixture. So that fourth line, b.quit, will quit and close and kill the WebDriver instance after the test is complete. Now that we've set up our WebDriver and we can use it, let's talk about the page object pattern, because that's how we'll be sending these web interactions to the browser. A page object is an object representing a web page or a component. There are two major parts of a page object. It has locators for finding elements on the page, and it also has interaction methods that will interact with the page under test. Those would be methods like login or search or get results. I strongly recommend we always send all WebDriver calls through page objects, because once we get to the page object code in a minute, we'll see how they can be a little bit complicated, right? Whereas when I just call the page objects, those method calls are short and sweet. They're readable, they're intuitively understandable, and they're reusable. So many tests can reuse the search page or the login page. For our test case, we really only have two pages to model. We have the DuckDuckGo search page and the DuckDuckGo results page. When I design page objects, I like to list not only what my page objects are, but all of the interactions that I'll need to do on that page. For the search page, I have two interactions: loading the page and searching for a phrase. On the result page, I have three interactions. Now the difference here is, instead of sending commands to the page, I'm trying to get stuff from the page. I need to get three things: the result count, the search query, and the title. Here's an implementation of that search page that we just talked about. I like to make a separate Python module in my project and put my page objects out there. Here I have it under the page.search module. I have a class called DuckDuckGo search page. There's a lot of stuff in here. And first, I'd like to draw your attention to that dunder init method. If you see that word browser is the input, that is supposed to be our WebDriver instance. That thing that came from the fixture should be passed from the fixture to that test case in pytest into this page object when the page object is initialized. That way, all of the interaction methods inside this page object know what browser we're working with. It's a form of dependency injection. And we have our two methods for our interactions right below that. The load method is the simpler one: self.browser.get self.url. The browser.get method is the navigate method. That's the method that will tell the browser to load a web page at whatever URL you pass in. And our URL I've declared as a quote-unquote constant at the top of my class. The search interaction is a little bit more interesting because it needs to use web elements. The search method will take in a phrase for which to search. And inside, the first thing it does, you'll see a call to browser.findElement. That is the browser trying to locate an element on a page according to some locator. And remember, the locator is a query for finding elements. My locator is this search input tuple, and I'm searching by name, where name is a particular type of locator that searches for the name attribute on an HTML element. And I'm looking for an element that has the name Q, because if I inspect my page, I'll find that search bar's name element is Q. So I'll call browser find element by name Q, and I'll save whatever that element object is. Once I have the element object, I can send more WebDriver commands to it. So as far as the searching goes, I need to send keys, meaning keystrokes, meaning simulated user typing. I want to send the keys for the phrase that I'm searching for, in addition to the return key. So it hits enter and submits the search. And that's all I really need in my page object for the search page. I also have an implementation for the results page in the GitHub repository that you can check out later. Now, I will also say from personal experience, half the battle with web UI test automation is finding good locators. There is more to say about locator strategies than I could possibly fit into this 1-hour webinar. There are many, many ways you can try to find elements. Most commonly, you'll use locators like IDs, class names, CSS selectors, and XPaths. If you want to learn more, I strongly recommend this Test Automation University course called Web Element Locator Strategies. It's free online for anyone to take. Just go to testautomationuniversity.com, create an account, and you'll find this course, as well as a bunch of other really helpful courses for testing and automation. As part of that course, you'll learn how to inspect for web elements. As part of my regular workflow as a test automation engineer, I love using Chrome DevTools. Anytime I need to find locators, I'll right-click, inspect on the page in Chrome, and you'll see the side window pop up that contains all the DevTools. I'll go to the Elements or the Source tab, and it will highlight any of the elements on the page connected with whatever their source is. So if I wanted to find the search bar, as is the case here, I'll highlight the search bar on the page, which will then simultaneously highlight the search input element in the HTML source. And I'll look at it and decide what's the best locator for this particular element. It may be a little bit hard to see because this is a bit blurry, but this input element had that name equal Q. So that's why I chose to use the locator by name for Q. As I said before, if you want to learn more about locators, definitely check out that Test Automation University course. So now that we have not only our WebDriver set up, and we have the page objects with all the calls, it's time to update our test case to make page object calls to interact with the browser. Back in my test search module, I've imported the page object classes from the pages package, and I've instantiated them as the first lines in my search test. You'll also notice that I have called browser as one of the arguments of my test case function. With pytest, whenever you declare arguments in a test case function, pytest will look for that same token name as a fixture. And if there's a match, then it will call the fixture before and after this test case. So calling it browser was no mistake here. Because I've called it browser, pytest will automatically call my browser fixture and initialize that WebDriver and pass in the returned reference into the test function here so that the page objects can get that reference. It's really cool stuff. With my page objects initialized and my browser initialized, I can then flesh out what those test steps were. And I'm going to keep the gherkin and comments because it's self-documenting. But then I'm going to put the Python calls below each one. So the first step, given the DuckDuckGo homepage is displayed, becomes the search page call to load the page. When the user searches for Panda, I call search page.search the phrase Panda. My 3 assertions, then the search result title contains Panda. I'm going to make a plain old assert call that the string Panda is in my results page.title. The next one, I'm going to make sure that my search phrase Panda is equal to the results page search input value. And finally, the last one, I'm going to assert that my results page result count for the phrase Panda, meaning the number of links on the page that contain that phrase, is greater than 0. I'm simply making sure that I got some links back that were appropriate. As a best practice, we always want to separate concerns. So that's why we should write assertions only in our test case and not in the page object calls. Page objects are an independent concern because they're handling the browser interactions, right? They will return whatever needs to be asserted, as we show here. And just like that, we have a fully functioning web UI test case with not that much code. It's pretty cool. If I wanted to run the test, I can easily run it from the command line using the pytest module. And if you've done it right, you'll see that one test was successfully run. And since I ran it locally and the DuckDuckGo browsers or DuckDuckGo page is pretty fast, it only runs in about 5 seconds. So now that we've mastered the basics, let's extend this solution. Let's scale it so it can handle testing multiple browsers and not just Chrome. Our current solution only runs one browser, Chrome, on our local test machine. That really doesn't scale very well. Web testing is slow. Order of magnitude, even though our simple test only took about 5 seconds, typical industry level web UI tests take anywhere from half a minute to 2 minutes each. Usually I find it's about 1 minute per test. You may think that's rather fast, but if you consider that test suites can have hundreds to thousands to tens of thousands of web UI tests, that adds up to hours and hours and hours of test execution time. And that doesn't scale well for continuous integration. Thankfully, we have 2 solutions. The first part is going to be using a tool like cross-browser testing. Cross-browser testing can let us test any browser on any platform. We don't need to maintain our own Selenium grid or install and set up our own device farm, right? With cross-browser testing, we can say, hey, I want to run remotely the latest version of Chrome on Windows 10, or the latest version of Safari on Mac OS, or the latest version of Firefox on Linux, right? All that is just a request away. So we can mitigate risk with a matrix of test configurations that we don't need to manage ourselves. The second part of the solution is taking that massive fan out of configurations and truly parallelizing it. And there's a plugin for that. It's called pytest xdist. It is a free and open source extension for the pytest framework. And I believe it's managed by the core pytest team, but I could be wrong about that. But with pytest xdist, if I install that as a plugin for my pytest framework, I can launch multiple tests at the same time in parallel on my test machine. And then, since each test would be calling out to cross-browser testing for their own individual independent web drivers, cross-browser testing can handle those multiple sessions in parallel in the cloud. So we don't need to worry about maxing out the local test machine. We can scale up and scale out with pytest xdist and cross-browser testing. And when we do this, depending on the degree to which you scale up your parallel test numbers, you can tremendously speed up the time you spend testing. We'll need to make a few changes to our solution to enable this. First of all, we'll need to add config data as inputs to our testing solution so that cross-browser testing can be reached, right? You will need a cross-browser testing account in order to do this. You can either get that as part of a license, or if you just want to test drive it like I did, you can get a free trial license for a couple days. When you get that license, it'll come with your username as well as your authentication key. In addition to that, you'll need to send to cross-browser testing your WebDriver capabilities. This is the specification that tells cross-browser testing What kind of WebDriver do you want? Do you want Chrome? Do you want Windows? Do you want something else? You can even specify things like older versions or screen resolution. All of that kind of config data, I personally like to put in config files. I'd like to separate that as a concern from my test automation code, because in theory, I should be able to run this with any cross-browser testing license or with any WebDriver capabilities. Those are things that should not and really should never be hard-coded into your automation code. And there are also things that should never be submitted to source control. Heaven forbid you submit your password to Git. Please don't do that. So what I'll do is I also like to use JSON format, and we'll see why in a moment. I'll make a config JSON file in the top level of my project and specify all these things. And I'll make sure that the controls are in place so it doesn't get committed. Once I've specified what my config data is, we'll need to read that file in. The best way to do that is just another pytest fixture. So back in the conf-test py module, probably above where you wrote the browser fixture, we'll add this cbt_config fixture. Its scope will be session level, referring to test session level, meaning we will run it once before any of the tests run, and that's the only time we'll run it. Because we only need to read this file once. Reading it for every single test case is a little bit wasteful. To read the file is really only 2 lines. With open file name as an object, my config data equals json.load. Reading JSON in Python into a dictionary object is nothing more than 2 lines in Python. It's beautiful. And once I've read in that dictionary here into my config variable, I'll make a few assertions on it very quickly to make sure that the config data is what is in the format I expect it to be. So I'll make sure things like the authentication and the WebDriver are there, and I'll make sure specific fields like username, key, and browser name are all there, because I want to catch that first before I launch a bunch of tests that could potentially break. And because it's a fixture, I'll be returning that config, so it can be dependency injected into my other fixtures and tests to access the data. Our browser fixture will also need a couple updates. So I will need to access the cbt_config fixture as part of my browser fixture because it's going to get those capabilities as well as the username and key. To call out to cross-browser testing, first we'll need to concatenate the URL for the request. You can see it in the first section here. I'm getting my username and my key from my config data. And if you look at the username, just make sure you replace the @ with the encoding, or else bad things might happen with URL formats. And the URL is calling out to hub.crossbrowsertesting.com with our credentials. With the URL then, we'll need to make the actual request for a remote WebDriver. And that's in the second paragraph here. So I read in my capabilities, I tweak the test case name using my pytest request, meaning the test case's node name, and then the Selenium WebDriver remote call with my desired capabilities and my command executor URL will do the work to make the request out to the cross-browser testing hub. And it will return a reference to the WebDriver that will communicate remotely with the browser that you've requested in cross-browser testing's cloud. Pretty cool stuff. So instead of writing Selenium WebDriver Chrome, we now write Selenium WebDriver Remote with all the specification. The other parts of this fixture are pretty much the same. We'll still have an implicit wait, we'll still yield, and we'll still quit. The only advice I would give is you probably want to increase your implicit waiting time, because now that you're making a remote call, network timing is going to be a bit slower. Now, that's all we need to do to get cross-browser testing working. We don't need to make any changes to the test code because the WebDriver interface is the same. So what I'm going to do now is I'm going to run my test live to show y'all how it works. So first of all, I'm going to start with my cross-browser testing account. It's at crossbrowsertesting.com. If you've got an account, you can log in. It's got a really cool command center here. I want to go to Automation and View Test Results. And you'll see this screen here. As of right now, I don't have any results because I've cleared them out. But we're going to add one right now as I run. So I have my test project open here in a terminal. You can see SmartBear hands-on UI testing. And I'm going to run the pytest command. And I'm going to move this out of the way. And as soon as I run this, you'll see some stuff happening in the browser. Okay, so it identified the test. It started running it. And should see stuff happening soon. Refresh here. So nice. So we see the test, it passed. It took about 13 seconds. And you'll see now that I actually have the test results in cross-browser testing. It was a Windows 10 platform, Chrome 75. This was the name of the suite concatenated with the name of the test case, or test basic DuckDuckGo search. You can see all the commands that were posted to cross-browser testing, such as the getting the title, the posting the elements, all that cool stuff. And what I've also done in my code is I've actually made some additional calls to the REST API for cross-browser testing that will automatically set things like whether or not the test case passed or failed. And I also added the capability to record a video. So if we watch the video here, this was the test, as you can see, doing the search, viewing the results, that my test case just automatically ran. The video capture can be really helpful for debugging things and for seeing why things failed when they fail. So really, really cool features here with cross-browser testing. And if you want to look at the code real quick, I use Visual Studio Code for most of my Python. I also use PyCharm, but you can see I've got my test case here, the DuckDuckGo search test case, and my conftest.py has the fixture like we saw for reading the config. It's got the browser fixture, which we saw the example code of. And the extra fixture, this uploader, this is what's adding things like starting the recording of the video, stopping the recording of the video, and posting test results is just a REST API call. All of this is in the example project on GitHub, and I strongly encourage you, check it out after this webinar. So that was a lot of information in a very short amount of time. And it can only scratch the surface of what web UI testing is all about. But I hope it was a helpful introduction, and I hope that y'all felt like you learned something valuable from it. If you want to learn more, there are some example code and tutorials I can recommend. For example, this webinar's example code is at that GitHub project. So here's the link if you need it. Also, about a month ago, I gave a tutorial at PyOhio covering almost this exact same thing. So you can check that out on GitHub as well at my PyOhio 2019 Web UI testing project. You can go to Test Automation University to check out that Web Element Locator Strategies course I mentioned, as well as the another course, BDD with pytest BDD, could be helpful. And there's always my blog at automationpanda.com. So that's my presentation. Mr. Nick, I guess we can open up for live Q&A now.
Yeah, no, thank you, Andy. It was a very insightful presentation. I just wanted to thank you again for taking the time out of your day to give this presentation.
Oh, my pleasure.
And before we start the Q&A session, I'm just going to launch a poll quickly, if you don't mind responding to this. And maybe along the way, we can start with some of the questions as well. So, Andy, are you able to see the QA section in there as well? Should be
Yes.
at the bottom. So I don't know if you want to kind of go through here and just pick out some ones that maybe you can answer right now.
Sure. Let me open that up. Q&A. For some reason, it's not showing.
All right. Well, maybe I can read off a few of them for you.
Sure. That'll be helpful. I'm sorry. It shows the Q&A. I just can't. For some reason, it's not displaying. Whoops.
Yeah, no worries. So first question, is there any page factor pattern in Python, same as in Java, which greatly optimized the POM pattern?
Oh, that's a great question. I don't know of any offhand. I know there are a few projects out there like Selenium Base, or there are some other companies out there that provide some SDKs for the Selenium API that take care of a lot of those things. Oh, one that came to mind right now, Splinter. That's another free and open source package. Personally, I kind of like to just use the regular Selenium UI or Selenium API because I'm just used to it, and I find that's transferable across all the different languages because I don't do things just in Python. I do them in Java and C# as well. But I'm sure if you just did a quick Google search, you'll find things like Splinter, you'll find things like Selenium Base, and they'll kind of expedite your page objecting a little bit.
Great. And then one more, let's see. How do you automate CAPTCHA, for example, on a login UI?
How do you automate CAPTCHA? That's a great question. I've never had to do that before myself. I would assume that there's some sort of web element you could click in there, or there's some sort of thing on the page that you can hang off of to get that element and send the click. Now, I don't know if there would be special magic involved because CAPTCHA is supposed to treat it like a human and not like a robot. But I'll have to look into that and get back to that one.
Okay. And then an anonymous attendee asked, what Visual Studio Code extensions would you recommend?
Oh, great question. Definitely the Python one. I don't think it comes out of the box, but you can just go to the plugins, get Python. It's now maintained by Microsoft, so it's fully official for Visual Studio Code, Microsoft stuff, and it's amazing. From there, there are some additional ones depending on the kind of projects you may or may not be doing. I do some Django web development, so there's some Django templates in there that are really nice that you can download. I do a lot of BDD, so the different Cucumber-based or Gherkin-based extensions for Visual Studio I find to be very helpful. And I'm sure for other big Python projects, maybe if you're in the data science world or something, I'm sure the Visual Studio has something for that too.
Great. And someone had asked if the GitHub link will be shared afterwards. And the answer to that is yes. I will be sure to include it in the email follow-up with the recorded presentation as well.
Nice.
And let's see. Does pytest allow to run tests in parallel locally on one browser?
In theory, yes. Now, I guess my hesitation is to say on one browser. I'm going to say yes. You can use pytest locally for using one browser type or multiple browser types. If you have your solution set up such that every single test case is going to get its own WebDriver instance. You can put in however many you want for pytest. You can say, hey, I want to run 3 tests in parallel. Those tests will kick off, and then you'll see Chrome come up 1, 2, 3 times on your local machine. Some caveats with that. The more parallelization you do on one machine, the slower it's going to become, right? Usually I find that more than 2 browsers per processor on your machine will make it will hit the point of diminishing returns to where it'll be slow, Selenium might have problems, and you're just not going to get the speed up that you'd like. Furthermore, it also depends on the browser type. I found that with Internet Explorer, you can really only do 1 instance of IE per test machine. So if you try to do multiple, some weird crap happens and it's not pretty. So that's why I'll say you can do web UI testing locally in parallel, but you're not going to be able to go very far. You're only going to be able to effectively get a few simultaneous sessions. And that's why you want a tool like Selenium Grid to scale out or a tool like CrossBrowserTesting that takes care of scaling out for you.
Great. And let's do maybe two more. So how would you handle dynamically generated objects?
Dynamically generated objects. I guess I need some more context for that particular question. If we're talking about like dynamically generated page objects, like if something, or like on a web page, if the web page is dynamic and something changes, and then you need a new page object, I would say first of all, your page objects should be they should be stateless, so that it only has locators. You're not storing any data, and you could create page objects only in the moments where you need them, and then trash them later. So that way they're very local in scope. If there's some other sort of object we're talking about, that might be just a test automation detail that would need some more context to fully understand.
Okay, thanks. So I'm going to end this poll here, and I am going to actually launch one more for our attendees, just asking about the level of familiarity with Selenium. So if you can just answer that, that would be great. And we can end with maybe one more question here. Do you have any experience executing pytest in Selenium from Jenkins?
Oh, yeah. Definitely. Yeah, Jenkins is great. I love Jenkins. There are other CI solutions as well, like Travis CI, Circle CI, you name it, it's there. At my current employer, we use TeamCity. So, I mean, to me, they're all the kind of same thing, right? You have some sort of build server CI system. But if it's Jenkins or something else, it's really easy to integrate pytest. There will be some sort of like package or module for a plugin to any of those platforms that will give you a nice user interface to do it, or you can just drive it through the command line. And that I typically do the command line thing just because it's simpler. Python is very command line friendly. You don't need fancy bells and whistles. But yeah, all you would do is in Jenkins, what I recommend, anytime you want to run tests, you would check out your repository, the code in your repository. Then you'd probably want to create the virtual environment in Python to give you all of the dependency packages locally. And then you just run the pytest command. And pytest has a flag that will let you save your test report in JUnit XML format. And that's really, really nice for all those CI servers because most of them will automatically show result charts and reporting and history when test cases publish reports in the JUnit format. So I would look into that particular option for pytest, and it should be nothing more than just a few command line calls, and boom, 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 you can have these Selenium-based tests running in Jenkins, no problem.
Great. Thanks, Andy. And that concludes today's webinar. I want to thank Andy once again for giving us an in-depth presentation, and hopefully you were able to gain some tips and tricks with working with Python, Selenium, and cross-browser testing. Be on the lookout for an email with the recording as well as a link to the GitHub link. And if there are any questions that come up prior to that, you can reach out to nicholas.brown@smartbear.com, and I'll be sure to follow up with any questions that you may have. All right. Well, thanks, Andy, and thanks to all the attendees that joined us today.
Thanks, y'all. Appreciate it.